Good evening, class. How are you guys doing?
Good, thank you.
Awesome. Thank you so much for responding back. I hope you all are doing well. Today is again Thursday, week of 11. We're going to start the lecture for this week, which is week of 11, 1102, 2000, actually not 1102, 1105, but the week of 11 is 1102 through 1108. And today, Thursday, is 11.5. We're going to cover continuation of regular expression, as well as the assignment on the regular expression, as well as show you some web programming, CGI, and other related HTML or HTTP protocols, because next week when we cover chapter 12, I want you to be ready for a network programming, which would be related web APIs that we will cover. Again, what I'm going to cover today on today's lecture, some of it is continuation from the 18 or 19 examples we did with regular expression, but it is also examples with UNIX, which we're going to cover a number of commands and command line arguments from UNIX as operating system, as well as from Windows, as well as Python, CGI script, and regular expression patterns. So let me go back to today's topic, today's agenda. Actually, let me see, that's week of 18. The good news is for each of these ones, I have some application demonstration, so you can see where these regular expression is applicable. That's why I'm covering to make sure you understand how you do it on different operating systems like Linux, Mac, and Unix, as well as Windows with regular expression, because as I mentioned last lectures, the regular expression is used everywhere. No matter which programming language you use, the same knowledge, whatever you're learning and the method data about the regular expression or the syntax of regular expression is going to help you in general for all programming language, whether it's C, C++, Java, JavaScript, Perl, Python, anything. So those ones all support regular expression configuration. And as you know that we already have the PDF files that last time I showed you. I'm not gonna go over those ones today. It's just this PDF file, and then there's a quick guide also that will show you this one quick guide, which show you and the regular expression. So somehow this one is having an issue displaying it. I'll check on it to see why later. But with today's topic, we're gonna cover Python, Unix, Linux regular expressions, and we're gonna search for. Do the grep command. Grep basically stand for generalized regular expression parser. egrep is for extended grep command, which is an enhanced version, so you can do multiple grep command. fgrep is for fixed string grep command. awk is the awkward programming language that, as you're familiar with, it allows you to do it similar to bash scripting in Python. You could do a scripting with for statement, if a statement, while statement, as well as parsing regular expression parameters, which I show you as well. And awk is the new awk version that was enhanced version of awk, and the newer version. That's why it's called nawk. And then the gawk is the new version of awk programming language. Sed is the stream editor. As you see, the name stands for SED. That's the stream editor for Unix platform. Originally, they started with ED. When Thomas and then as both of them, they started off with building the Unix operating system at AT&T Bell Laboratory back in 1969. And they just started off with ED as editor. And then later on, and they just add on VI, which is stand for Visual Interpreter, and or later on in Linux and Mac and Unix version of the operating system, they made the VI M, which stands for Visual Interpreter Improved. M is for like IM is for improved. So a new version that has more capability than just regular VI. But sometimes the VI is also a symbolic link to Vim. So no matter which one you use, you always use the later version. We will go through some of these ones. The reason I mentioned these ones are that regular expression patterns that matching that you learn, you could apply it with all of these commands, whether you're inside of a programming language or you're just using editorial to do it. You can manipulate text as you like, and that's the one we will cover. And also, we will be covering the Python, Unix, and Linux CGI regular expression. CGI stands for Common Gateway Interface. So normally when you're doing web programming on the back in the old days, they are still using CGI extensively. The reason is that it is a very good interface in terms of running some code on a server side. Because sometimes when you're connecting through HTTP, you could call a lot of different APIs through HTTP. Whether it's HTTP port 80, which is non-secure port, or HTTPS port 443 by default, if you don't specify the port for HTTP, if you're going to like google.com, for example, let's say I go to google.com here, you can see that the URL changes to HTTP colon. This one is actually with a secure key. You can see that this has a certificate. So it goes through SSL certificate there. And then whether I type in this one or I type in like this, google.com, it is assumed automatically it port forwards to secure port. So if I type in HTTPS, google.com is the same thing as the same page. So the same page comes in no matter how you do it, because the port 80 is port forwarded to HTTPS. So in case of our unix.com, I'm port forwarding, if I go here on default port, I'm port forwarding it to HTTP port 8080. 8080 is going to take me to that port and automatically serve that page. So right here, actually, the URL is colon 8080 is the same as this page. So this page is going to bring me the same screen, whether I type in this or not, because I'm port forwarding that one to 8080, it will respond. And there's a server side that this process comes in. So if I go to like, okay, this is the book, I want to just teach Unix on it. This is all kind of like hypertext protocol through HTML code or CGI. So right now here you can see table of contents, HTML. This is all HTML code. So if you go right click here and say view source page, you can see the source page is all written in HTML code. This is all HTML code. And then some of the URL that is saying that show the images, and then you can see that they are listed. And if all the information here is basically HTML code from top to the bottom. But if I go, sorry, let me move this thing here out. Okay, so if I go here and then let's say I go to chapter 2 of this book, I'm showing chapter 2.html, so it prints this page. This page is in a tabular form. Still, if you look at the source code of this one, page view source, you will still see HTML code, but it's some tables and some kind of information. But as you click on it, on these ones, then I'm going to call a CGI program, like for chapter 2.cgi. This is the CGI program that will be passed on with this argument, chapter calendar.html. So if I just go back here, and this one, and then look at the calendar, for example, the calendar command, you can see that as chapter 2.cgi comes in, and then the argument to the key pair value. So sometimes on a CGI program, you could do certain action. The action could be a get method, or could be a post method, or could be a delete method, or some other method. So let's say it's a get method. The get method requires a key pair value. Like you learn in Python a data dictionary, so your key pair, the command is the key, the value is cal-html. So if I look at this calendar, for example, I click here, my CGI program is going to run this command on the Unix site, and it's going to just output the calendar. So you're sitting in a front of a browser on a Windows machine, but you're executing Unix machine. So here, if I just happen to change this calendar command to calendar 2020, you could see the data that comes in from the server side, it is dynamic. So this is not like one command that you could do. If you do a df-h, I could see my information here on the system. If I do, say, tell me what operating system I'm running, UNE-A, it says you're running Sun Solaris version 11.4, and then if I say, okay, that's good, show me the information on OS release, which version is it? Solaris 11.4. So it comes in, and I say, okay, that's good. Let me see what is the processor information, PSR info. So all I'm doing is I provide through the CGI script a method to execute some command on the server side. Why am I showing you this example? Because eventually on the system, you're going to write either some REST kind of API, some kind of SOA kind of API, some kind of request method, some kind of CGI modules, whichever one you choose to do, depending on your needs, you are going to do some sort of client server or manipulation that the data is on the remote side, whether you do RPC, remote procedure calls, or RMI, remote method invocation that we talked about Java and Python through RMI calls. It is just your choice, but with the CGI, you have certain functionality, certain features. With REST architecture, you have certain functionality. With SOAP, you have certain protocol. They all use the HTTP protocol or HTTPS for secure port configurations. Depending on which method you use, if you use the SMTP, SOAP, SOA, REST, CGI, any of these REST full API, any of those methods that you use, you're basically doing some kind of data manipulation either on the server side or on the client side or both sides. On the example of CGI, the actual request is made from the client originally. So in this case, I was logged on my machine here, and then I'm running this CGI script on the server side. And that's CGI pass in the argument here. If I just say execute this command ls-l is going to run on my server side, and it's going to just go and run ls-l, give me a long listing of all the files that I have. But when the request is made through, in this case, the action I'm doing is get method. It is passed on to the CGI script. The CGI goes to the server side, execute this command on the server side on the Unix Solaris operating system, then it fetches that record back to the HTTP protocol, and then my browser is going to just display it back to the screen. So what is the advantage of doing so? In this case, if you're learning like Unix, for example, sometimes you install virtual machines to do it. But then what if you don't have a machine? You just have a browser. The advantage of this book that I wrote, The Direct Way to Solaris Express, it gives you a direct way without having to install Unix or Solaris or Linux or Mac or Windows. All you need is a browser. So you could open up your browser and just type in our unix.com, and then this comes in. And if you say, okay, depending on what level of learning you want to do, if you want to learn the basic Unix commands, and these are the examples here. This one will give you basically the about maybe 3 times 8 is 24 or whatever that one is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 times 10 is that 30 different examples. But each of these examples, like you can click here, cat, I'm showing you some other examples. So here you could see what is the cat command do. Cat command concatenate files and prints on the standard output. So if I'm on a Unix machine, I know that I can do cat -n for new argument and then etc hostname network like this. And then you could see the output is getting there. And then you say, okay, now I understand what does that do. What is, let's say, cat -n etc release file. This is just a release file. It shows that one. There are 3 lines in there. It will just show you line number as well. So if you just learn that one, then you could just say, okay, now let me get the date command. How does that look? And then some of the commands, if I don't want to run it on the system, like here you see November 3rd, it's dynamic. As you are running on the system, whatever date time is on that system, it will display. And then I'm here as well showing you some of the commands. But going back to the CGI script of that HTML, I don't want to get off of the topic why I'm showing you this. So let me go back. This thing is too much on the side of it. Okay, that's better. But I want to move it on this side so I can see the, okay, that's good. So here, if I'm going back to our agenda, you could see that I'm talking about CGI, which stands for Common Gateway Interface. So what's happening, what is a CGI? A CGI is a program that from the client side, from one machine. The client machine doesn't have to be a Windows machine, does not have to be. Any machine can be a client, even a cell phone could be a client. Basically, the client from a browser side and from HTTP or HTTPS makes a request, and that request is either through a GET method or a POST method or a DELETE method. There are certain methods that are available for it, and then you just have to do that one. The action for the GET method, for example, has different advantages versus POST. GET has action that you are passing the argument and key pair values. Like here, you can see the URL is there, and then after the question mark, there's module underscore item, and then this. So whatever the key environment variable that is passed on, it will have some value. This information, the entire key pair value in a GET method is called query string. And there's a list of query string, which I'm going to show you using this script to see how you can print out the list of variables. And then the environment variables using the OS module of Python. For example, here I'm importing OS module CGI module and CGI traceback module. I will explain each one of them, what they do and why I'm including them. But once the request is through, this URL is passed to the server side, the server runs the request. If the request is to run a UNIX command or a Windows command, it runs that command on that operating system and it fetches the result back to the client. And the client, the browser parses it and it displays it based on the way that the CGI program was written to how to display it. But if the request is made to just post some documentation, and instead of the get, you have a post method. The action is post. Post and the get is actually 1024 because it's almost like this key pair value. You cannot go for so long, but the post has a bigger data buffer. You can post more than one page, more than 3 pages documentation through the post method, as well as the get method has security issues. So you cannot pass in login and password through key pair value, because whatever is on the URL, people could just hack that or read it through the network, and then a packet sniffing, they can read and do some kind of packet sniffing and then know what parameter was passed to the user ID and what parameter was passed to the password. And then with the post, you can actually do different methods of using the authentications, and that way the password is not going to non-secure text, clear text kind of values. So what you could do with post, you could do it certain ways to pass it into an environment variable, and that environment variable is within the session that it comes in, dynamically creates on the program, or read it from a database, or read it from an LDAP server, pass it on as it is going, and that reading from an LDAP server or a database or a password file, all that information is coming is still in encrypted forms. So whether you secure SSH to the machine or you do through a post method, the authentication is protected. The authentication mechanism is not passed on as clear text. In this case, I'm doing the get method to just call it for that program, which we called it here with the table of content. So like here, if I go back to another chapter, somebody learn all the basic command they want to learn intermediate level. So this is the chapter that you could do that one as well. And then like, for example, let's say you do a DF, see the system kind of like, okay, show me ZFS file system as well as other file system. You could do DF minus H with kilobytes information, DF minus H for header, minus K for kilobyte information, minus H for human readable stuff. You could do all kind of different syntax, and there's man pages as well. But let's say I'm going to learn all of this and I learn everything one by one, then I want to do advanced. As you can see that this one is chapter 4, and it is about more than 120 or 30 commands here. And each command that you learn, you could click on it. There's more commands and more examples here. So you could say ZFS list, and then you get the output of this. And if you just say, show me the ZFS snapshot, you could either come back here, run this one, or just pass in the argument the way you do here. Minus T means the type and the type of the data that you're looking for, snapshot. ZFS file system stands for zettabyte file system. And Solaris and Mac, they have this file system, which is so robust, 128-bit file system, which is very efficient in terms of speed, as well as it's very, very secure. And the data, it's called zettabyte file system because they want you to have a Z pool, which is a pool of storage. Then you can grow terabytes after terabytes of data, but you will never run out of space on your storage. So you can always increase the storage by adding more disk. You don't have to say, okay, those are the disks that we had maximum of 20 terabyte. Now we have to upgrade it to 30 or 100. And those other ones are gone. They're useless because they were this other format and we cannot increase the size. But with zettabyte file system, you just run the command to just increase it. And then with the system administration security aspect of it, it's so robust. It's give you so much nice stuff. And in order for me to just like help people, something like ADB for advanced debugger, and some of those ones, I cannot just run certain commands on my operating system because the hacker could just delete all my files or cause some issue to my system to be down. So I'm providing those ones in a HTML format with that syntax with the help so people could go and read it and understand what we're doing here. This is all low level and then high, you know, kind of like system administration, that advanced level. You're not expected to learn any of these ones today or tomorrow or maybe next week. Some of these ones, each one of them could be a class by itself. But the ZFS example that I was giving you here, I just have a chapter for that one as well. So there's a chapter for shell programming that we could do, and I could do a chapter for Python programming. We could add on to this kind of documentation. This is a web server. So the web server Apache that I'm running this interface itself or in this browser is Apache, and then I'm having documentation for that one as well here. And then the last chapter, which is chapter 7, is all ZFS file system. So the ZFS, like for example, detach, attach, offline, all these commands, you can grow the ZFS by doing these commands. So it's so easy to just say ZFS attach and then attach something to it. And then if I don't have the command here, because I'm not doing certain things with the storage, I just don't have a page there. Maybe I could just have certain, but if I have like ZPool documentation on it, the ZPool list, it will just show the ZPool list here. Certain things like zone EDM or something, those are UNIX command like ZFS create. You cannot outsider to just use your tools to create it. So I'm showing it here. And like here you have ZFS list, and then this is how you take a snapshot. This is how you get all the RPool parameters, and then you go on and read and understand how you do it. And then this is how you format on Unix, a disk, like in Linux and Windows, you have fdisk or partition, part-d, and there, here you have format command as well as ZFS is using that file system. So let me go back on the module here, and we are going to explain here. So far, do you guys have any question? Okay, I see 9 students there with, 9 with myself included. So we're all learning. So I'm going to be one of the students as well. So here we're going to talk about this module, a CGI module program. The program is called env.py. As you can see, cat minus n env, this cat command in Unix, it displays the content of it as we were just looking at the other example. Cat minus n shows the line number in front of it, and env.py is my script name. So this is the user ben env, the first line. As you can see, we were using on Windows, we were saying pound bang, which is called shebang. This part is called shebang. This shebang is basically similar to Windows, but instead of the Windows Python, I'm using user ben Python. This I could say user ben env Python 3 would be more easier to make sure that I'm using Python 3. If this system is using a user bin Python 2 by default, it will run, but if my code requires Python 3, then this code will break. So if I'm using a F string or something, and then Python 3.6 is not, 5.6 is not there, then it will be a problem. So this one by default is Python 2.7, I believe. Let me just log in. So one method that you can log into a Unix machine is using a client. In this case, I'm using Bedwise. Bedwise SSH Client is secure shell client. It's a very good client. It is free on the internet. You can download it. It's called Bedwise. It replaces a lot of the previous client that we were using. It's one of them was Putty. Putty was very nice as well. It does give you a lot of functionality and features, but Bedwise has a little bit more GUI, as well as it does give you one thing that Putty and let's say other software that you're using through secure SSH or something that you're using was Bedwise is better. What is better is that once you authenticate, if your browser somehow locks up on you, or you walked away from your computer and you come back, your screensaver kicked in and now your connection was lost, you can come back and re-log in by just clicking to a button, say new terminal. Let me log in first here. So now all I'm doing is providing an IP address. I could type in the host name, but because I was connecting through my local port, through local IP addresses, I just put that one. This is my user ID in this case, and this is the port that I could connect. Normally, you want to protect those ones from other people knowing what server you're authenticating, what is the OS version, what is your user ID. Of course, if you just do it for demo version, students, you have to be a little bit maybe open, but in terms of security, you have to make sure that what you're doing is not opening something like a loophole on your system that later on bites you. So here, like here, you see that, let's say my screen locked up or I close it, all I have to do here now, come back on new terminal, click on the console, I just have a new terminal. And then if I just say on this system, what is the OS name, like I was doing here, say cat etc os-release, this one is there, but if I do a -n earlier that we were doing, it would give 3 line numbers. And then OS, so this one is our Unix, and then if I say os-version, I'm sorry, OS not version, etc host name, you will see the host name. Any file that you're looking at it, you could see through this. And if I just clear my screen with clear -a, you can see it as a Solaris and there, and then cut -n etc os-release PSR processor info. So processor info, it tells me I have one processor which is online. If I wanted more detail on it, -v for verbose, I could get the output for that one. It says it is this speed, it's i386. So basically, this is a machine running off of another machine, which is VirtualBox. Let's see, grep -i. So here, this one would not show you the VirtualBox because the virtual, this one is part of the virtual there. But if I go to my main machine, still -l, mywebuniversity.com, and then log in there, which is my actual Linux machine that I'm running VirtualBox on it. So let me log in with the password. So now I'm logged on, I clear my screen, and then host name here, now it shows mywebuniversity.com. This is a different machine. It's a Linux machine. And then cat etc os-release of that one is going to show that this is Ubuntu Linux, right? So all of that information is there. Why did I jump in here? Is that I was saying that when you look at the, sorry, so let me exit out of this one back, and now I'm there. If I just, yeah, VirtualBox, that's why I came back here. I forgot why I was there. So let me log in again, -L. This time I'm gonna do the wlutfi. I could just say it like this also, wlutfi@mywebuniversity.com. So I log in there and then clear my screen. This one is my web university, which I'm hosting in the VirtualBox here. Inside here, if I just say the VirtualBox command, VirtualBox dash list dash running VMs. Okay, so this one would not show because of the, I have to be in an X window GUI session in order to get this information. VirtualBox manage dash list dash running VMs. I could do list and dash. Let me undo this help and then grep -I running VMs. So this one is the syntax right here. If I do that one, I have to do it with this syntax, which is VirtualBox and then a space list, not dash list, and then either VMS for virtual machines or running VMs. So if I do running VMs, and then it will list one of the VM, which is my Solaris box, and that is running. But in this case, it is not showing it because I'm not in a GUI interface. But it should have shown here. What I do is grep -I VirtualBox, and you can see that it's this one is the process. So all this information based on this process, I can do LSOF on the process and see the list of files that are open for this process ID, LSOF -P 3475. And you can see that all the things now, so I have to do this is current working directory, root and execute. This is in the proc file system. This is too much details to go through, but if I go sudo su dash and then log in as with sudo privilege and then run the same command, now I am not gonna get permission denied. Sorry. And then all the processes that were open on this one, it was listed, including the shared files and everything else. And then we're going to cover next week socket and piping and everything else. All those information that are passed on, you can see that it's here. So let me go back to my Solaris machine by exiting out of here. And then this is Solaris machine here. So clear the screen here. And in order for me to demo this example here, I'm gonna just go to this actual script here. So go to var Apache 2.4. So this is my Apache server. Like I was telling you, HTTP process. The Apache is running off of this directory with HTTPD as daemon. But in order to actually run a CGI script, I have to have a directory called CGI-bin here. Inside the CGI-bin, all my CGI script, including the, so inside here, including the env.py is there. And the ownership of that file, you can see, is executable by everybody, but the owner is W. Lutfi in this case, and the group also has read, write, execute, but not write, only read and execute web serve. So people come in, they come in with web serve. So now env.py, you can see is the exact script that we're looking at here. Use a bin Python OS CGI and CGI this and there. Now I'm ready to explain line by line, but let me ask you one question. Do you have any questions so far on this? No question? Okay, so why am I covering this one? Let me ask you this question. Why am I covering this? Because Python allows you to do a lot of these modules, and then we already covered the basic building block of Python, which was list, tuples, data dictionaries, and we covered regular expression, we covered if statement, for statement, while statement. Now here's the application of a regular expression or OS module, how you could use the OS module to do certain things on your system. But if you don't know the application of something, sometimes people ask you at work, say, can you write this program and to do this one? Can you write this calculator because I need to do this? Can you write this form to just display some information on the web, and then people are going to give their data back to us, we save it to a database. All that request comes in through some kind of application needs. Where you apply your skills is basically you have to figure out some method to just write an app somewhere, write money apps. Whenever you do those kind of things, your skills is just kind of like as if you're learning math. If you don't work on it, you forget the logarithm, the integral, past, whatever functions that you learned in the past, in the high school or college, you're going to forget it if you don't do it. Similar with programming. If you just refresh your memory and play around with it, just for fun, you could practice it, you still learn it. So here, this Python is there. And what does this script do actually? Let's see through this. I'm going to open it up here. And then I'm going to make this screen bigger so it fits it up to here. And that way we can see it better. Now I'm going to do a VI and then env.py. Remember the example of VI? I was going to show you the grep command and other ones. I will do that one. But here's our chance to look at VI or vim. So this is, I'm going to open it. Now I open the file in vim, VI. So if I'm just going to want to just do the stream editorial command, right now I am on the, by pressing escape shift, you will get into the command editor. At this time, I'm just going to put a command, say set NU for line number. So you can see the line number was added there by default. If I want to take the line number out, it says set no NU, and that would take the line number out. So set NU give you this. But now if you want to just look for those control M characters, some other kind of characters to make sure that they are not having non-visible characters that prevent your code to run, you could run escape shift and you say set list. Set list will just give you all the tabs and all the control characters. So in case if I have a tab here, let me just put a tab here. If I do that tab, notice every time I press tab, it puts control character, control I, right? So now if I want to use the set, I'm sorry, not the set, the stream editorial, which is set in this case, or within VI, to do that regular expression control I character to get rid of everywhere that is control I and replace it back to nothing, I can do it on line number 10 because I know it's on line 10 only, or I can do it on the entire file. If I do shift, escape shift, I could do 1 comma 11. That would cover line 10, or I could say line 10 to 11, or I could say 1 comma $sign, meaning that from line 1 through dollar end of the file, modify anything that you see, Control I. But what is the command? The command is S for stream editorial or substitute command. And then what is the argument that I'm passing on? This bracket, once I start, then this is the command that I want to put here, and then this is the command. So the first string, the space that I'm having here is Control I, which is thing. So let me just do that. I'm going to, in Unix, if you just want to write those non-visible characters, rather than doing this, so something like that, and then put an I, which is not the exact thing. That's not tab. So in order for me to produce tab, I'm sorry, let me just go back here. So let me, I just updated something here. So in order for me to delete this one manually, I could do escape here and then put this line here. But let me just add some control characters. So escape, I for insert, and then tab, 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 and then say that. So in order for me to change that one, I cannot do encore in the I to replace it, because that's an invisible character. As you can see, if I just say set no list, that one is not going to show, but here is basically non-visible characters of tabs. And now if I just go here, say, show me all the non-visible characters, so show list, you could see these are tabs. Okay, so by doing a set no list, you see that it shows as a space, but those are not a space, those are tabs. So in order for your regular expression to match that one exactly, you could just say set a list. I'm putting it as it is. Now I'm going to say from line 10 through 11, or just go on line 1 through $, meaning that anywhere that I have a tab, get rid of it. So I'm going to say substitute. Now I start with what? Control V, I press first, and then press tab. That will just do exactly as the Control I character that it shows there. Now replace it to what? If I just don't put anything, I just put the next one, G for globally. But if I want to replace it, this one to Wahid, and then change it there, so every time there's a tab, it will just change it to Wahid. You can see that. And if I just do on VI, say undo, it is just by escape U, it just undid that one. So and now if I just go say, okay, run this that command and substitute Control V, Control tab, and then just get rid of it, and then this time get rid of it. And then this space is, even though I just force it to have two space, I could get rid of it there. So the configuration of something changing to something, it's much easy. So if I just want to say change an inside VI, I change line 3 through 5 from import to just say include. For some reason, I just don't want to use the import command. It doesn't make sense, but sometimes you want to just do write your code in one language, and then you convert it to C, and then just instead of OS, you say streamio.h or something, whatever you want to decide. So I could say line 1 through 6, and then substitute. So this slash thing or this backslash is my choice. So in this case, I want to use slash because I don't have another slash there or another character. So I could say import, change it to include. And now you see that I changed that. And then if I just didn't like it, I say undo. So here, this code is doing this. And then the first line, since we run this code, we're going to save it. And then we are giving the three modules: import OS, import CGI, import CGI traceback. The reason we're including OS because we're using some OS module like os.system to run some command. If you do sub-process, we could include sub-process, which is better than just OS modules, a certain functionality. The CGI, in order for me to get data from the web and then get the key pair values information from the get method and other ones, then I'm including the CGI method. And CGI method has some kind of a storage field that I can get those key pair values from it. In this example, maybe I don't need it, but later on I'll show you another one you can actually need it. So this is CGI traceback. Sometimes when you're running your program on the web, you may just run the code and the code will never run. It will fail. If it does fail, your screen information will be displayed on the browser side, and your user might say, well, this system is broken, it doesn't work, or something. So in order to just save some of the embarrassing information from the CGI script displaying on the screen, you could do CGI traceback.enable and then save that information into a log file. This, in this case, is like a log. I could just save it to a log dir, but that I have to create it on the server side. So let me just put this one. Log dir. And then, so the display, meaning that the display is 0, meaning that whatever writes on the first display 0 normally is your a standard output, then it's going to be written on that one. In this case, send it to a log file. And then here, it will create its own files in there. And then the format, you just don't specify any format. By default, is the default format. You could do format with equal that to strings. So it will just save it in a text clear format. And then here, this is very important that whenever you're writing information to the web through the HTTP protocol, and the HTTP requires some sort of content type. Whether the content type is JavaScript or text HTML or some kind of media or something, you have to specify on the header of that page. So on Python, you say print, and then you use this keyword, say content-type, colon, and then in this case, because we're sending a text/HTML, this /character return and new line is basically a format that will put 2 new lines character. This is required for that content type. You cannot put 1 line or just something else. It will have some. So that's the syntax that you have to do that. And then after that one is your Python code. If you want to send Python HTML code inside there, you use this triple string. You just say my string is, and then from here until you close that string right here, you could put any format of HTML code with any syntax that you do, as long as the syntax of HTML code is there. Python doesn't care. All it does is that when you do a print my string, it displays that one. And that one with shell programming, Perl programming, another one, sometimes you use the mydoc kind of end of file variable that you could pass it on, and then the double less than sign to the string, and then you close it with that one, with the HTML code. So originally I wrote this one in Python, then I had to convert it on Perl, then I had to convert it in Python. So now it's Python. Here, this code right here, this is a kind of comments on HTML code. You start with this and you finish it. So line 16 and line 18 are comments, because I don't want to use this cascaded style sheet as my styles of the page. I want to use this one. So if I want to change it back, I could comment this one and I want to do that one. For different purpose, you have a choice to make it. This head slash HTML slash body, all of those are HTML codes. So inside the body, you have all the code that you want to start with, and then the variables that you want to display, and then so this one is env dot, so it prints out basically environment variables from the query string. But let me go to the CGI part of it. So right here, as you can see, once it prints the my string, which is the header information, then it's gonna do some Python coding on the server side. On the Unix, in this case, I'm doing a count is equal 0 first, and then I say for key in value and os.environment.item. Because I import OS, I'm going to use the environment functions with environment, in this case, module with item as the method. And then inside here, these items basically has key pair values. So I go through them, and then as I print out each key and pair, which on this case I commented out because I said, let me use the format method here and make a beautiful kind of like, make the text a little bit more beautiful with some HTML code, depending on whether the first line or the second line. So for each line, I'm doing a different format. By doing this if count mod 2 is equal 0, I change the color of the thing. So on the HTML hashtag, and these pound, there's 6 digit here by default. If you're not familiar with the way that HTML codes are working, the first 2 is for the red, the second 2 is for green, and then the last 2 is for blue. So wherever you're putting zeros, the absence of that one. In this case, I'm making it blue. So blue is 9.5. If I just do it like 5, it's very, very dark blue. So 25 would be dark blue, but and then 95 is just blue, and then a higher number would be light blue, and so on. And then this one, I'm doing like dark green. Dark green is, in this case, is just, I could do really dark green by 25 or maybe 10 or something, but I could just, I like that color of dark green, 55. So, and then I just use the format, and notice the format when we do this one, for each of the parameters, I'm using the color twice. One is here and one is here. So a position holder in this case is for the color is always 0. So I put this one there for the first parameter. This second parameter K is going to be this position here, and then that second parameter, and then last parameter here. So then here I'm doing a print statement before the for statement for the UL, which is stand for unordered list. And then here I have to close it. So right here, there's a slash missing. I'm going to put that, sorry. So the slash U in this case is open, and then the slash U. So when you're inside the VI, you have to press I for insert, and then insert it where you want. So that slash U is telling it that I'm going to save it with an order list, because every time you start a tag in HTML, you have to close it. In this case, it's closing it, so it's good. And then the rest of them is just basically further information. And then here, this one, I'm using the open statement with the file handle. Since I did not use the with statement with context manager, I had to close it with fd.close. So the file handle that I open, file descriptor, I call it here for this my footer, that my footer, whatever is on the bottom of it, it works that way. So let me save this one. And then now we come back here and we call it that directory. So I call it cgi-bin and then we call it env.py. And then the output is displayed here, the Unix Solaris environment variable. So here we can see the environment variable. This is basically the query string that I was telling you, that every time you go through HTTP protocol, you will be connected through HTTP by default on port 80, and then the queries that are passed on, each one of them, they have a value. Like context document root has the var Apache 2.4 CGI directory. So if I forgot something, like what method I'm using, you can see I'm using the get method here. And then query string is empty because I did not pass on any argument to it. If I just say cmd is equal pwd, of course, the query string has the parameter that I passed on here, right? So this is just the environment variable depending on what I do. Now, if I just say question mark, name is equal Wahid, and then question mark, let's say favorite sport is equal soccer. So I pass on, notice that query string is key pair value. For each command, and the the values there. If I just say instead of the command, I could say something else, and that would be one of the keys. So since I said command is equal pwd, it makes sense. Name is equal Wahid, favorite sports soccer. The query string just got passed on as I type it in on the CGI because I'm using the get method. And this query string, like I'm telling you about the get method has about 1024 bytes constraint that you cannot exceed that one. If you use something else, you have to do post to post a document with larger size. So all of these path, like what is my Unix path is showing here, and what is the server name, our unix.com, you can see the port that I'm using, server port is 8080, you can see. And then the IP address of my machine, which is 192. If I go here and save this information, and then do a fconfig -a, let me just clear the screen and do fconfig -a, you can see the IP address of this machine is this. And that file is also, that information is also on the host name. And that information is also on the status there, and that you could see. This is my default gateway, and then I had to configure. There's certain configuration on the network. Next week when we cover network, I'll cover a lot of Python as well as a lot of operating system. So you're well knowledgeable about both. And the reason I cover more than just what our textbook does, or what an introduction class is, not to show you off with so much knowledge, is to help you so much that you can just say, you know what, I learned so much on this class that I can just take the other class as if I already took that class. It is that knowledge is going to be duplicated for you that you're going to learn, but your grades are not going to be expected the same way that I show you in these commands. I'm not going to challenge you on the midterm or final, as you notice that some of you like the midterms and some of you are going to like the final as well. But you just have to follow the and convert Zoom. Every time I post a video, you have to attend online. When I'm showing you, have to participate, and participation is always encouraged. Every question that you ask not only helps you, it helps me, it helps other students. By just answering that question, maybe we clarify a number of other issues. So when we are looking at the IP address here, and going back to this example, you can see that the IP address is there. I'm sorry, did somebody have a question? Okay, so you can see that the name of the script is env.py. You can see a lot of information about the port and the host information. This query string, it gives you a lot of details. You can see the version of it and the request HTTP scheme is HTTP protocol, and the remote address, what is my client that is coming. So the client here in this case is coming from this machine. Sometimes people say, oh, you know what, I went to this Facebook, or I went to this browser, I used this tool, and now I'm getting these advertisements. A lot of the web server application, they set cookies on your machine. And what this cookie is, basically they just have a certain information about you. They want to save it in a file. Sometimes by setting up a cookie, they keep your session active based on what you're doing on those ones. And then sometimes those information is useful to yourself. Sometimes it's useful to the marketing for them. So they keep those cookies in order to just find out. So if I'm just interested in what the IP address of the remote site to say who is visiting my server, then I can save this information, say, oh, okay, this one is coming from this IP address, and then I could say, what is that IP address? Oh, it's a Frontier page. So here, like if I go on this machine, sorry, let me go to a Windows command line. Here, if I do a ipconfig, which is equivalent to the fconfig of Unix or Linux, ipconfig, it gives you that IP address of information saying this is like IP version 4 address, and then this is coming, but when I'm connecting to that server, it is sending this as IP version 4 client request to that one. So it knows that where I'm coming from. And if somebody from Googlebot hit me, and then I could get that from the remote address, I say, oh, okay, Google was searching on my website. And then we could see it. There were thousands of times that I saw that there was Google doing this kind of a search to pull data for this information. So when I go, like, for example, on the google.com site, google.com, and then say something like our unix.com, let's say our unix.com. If I just do that one, you can see that a lot of the information is already populated in Google and shows that on that each page there's some kind of information. So this is the page that there. So if I go here and say our unix.com /AD/, let me just go to mywebuniverse.com, see if that one page. Okay, so mywebuniversity.com port 8080. Let's see if it does respond to, yeah. So this one is there, but then if I want to go to man_pages, so for manual pages, I could see that there's documentation for it that I have there, or I could just go here, say our unix.com. And then this one is going to go to the URL because that URL is responsive, and then the other one was not. So through this web server, it goes through my main page. And if somebody wants to learn Solaris, Windows, PowerShell, there's documentation here. You could just get a documentation for everything. There's about thousands of pages of document here. So whatever you're interested on the commandlets for PowerShell, you just learn it here. You could just click on something like, for example, what is the is a method. You could see all those ones because of the object-oriented functionality of PowerShell, that an object, you can say, is this what type of it is, and there. So, excuse me. And then and install shell script and everything else. All of this is there. Here I was like open Solaris, like there's about 13,000 document here. So if you're looking for like a cat command to see this one, Control F and then type in cat, it will just see a lot of cat here commands. So look at 194 of them. So if you're just looking for the one that is specifically to that one rather than coming on this page, maybe what you could do is go under the Solaris here because I sorted by alphabetical. So let's say this one is Solaris and you're looking for a cat command and you type in, click on C, then do a Control F here, or just go here CAT, Control F, let me just do this one faster, cat, and then right here, there's a lot of commands, but cat is for concatenation. You could see the output here. And you learn it and memorize the syntax. It says, okay, I could do all of this and then play around with it on the Unix operating system. Similar, and this one is true about Linux. If you're a Linux person, you want to learn all of that tools are here. And if you're just looking for sorted order, there's again here. And this is for Mac and this is for Linux. They are all there. So if you're looking for like a Python documentation, you can go on, let's say under Mac, for example, under P here, and then do a Control F, and then look for Python. Now it's Python there, and you just click on it and read it. This is all through this one CGI program that I wrote on Python. I created thousands of HTML files that could produce that kind of display, and as well as the documents pointing to the right one, doing that one. So this is an application of it doing so. And here, when we are looking at this program, vi.env.cgi, let me, sorry, am I in that directory or not? Oh, so it's env.py, not env.cgi. vi env. So if I look at this screen, if you say file env.py, you can see this is a Python script. And then the file env.py, you could see that this is there. So I was telling you about grep, egrep, another one. Now here's our chance to look at the grep command. If I just look at the env.py, and then I say, okay, show me that one, but then only do awk on it. Let me just do awk, print $9. $9 meaning that only show me the file name here. If I want to say show me $1, it would say the read, write, execute. $2 would show me the one. $3 would show me the wlutfi, and then $4 would be web server. So as I move to the right is the next field. But what if I'm just interested on certain things? I don't want to just memorize what I'm looking for here, and then I say, okay, and do grep -i wlutfi. Now I picked up wlutfi because wlutfi is on this string. If I look for Wahid, -i means ignore the case. So if I look for Wahid, it's not going to find it. But if I look at -i with uppercase wlutfi, because the case sensitivity -i, it ignores it, it shows it. Now if I just say, do a count on it, how many are there, -i there. And then if you say that, show me the line number, you could see that the line number that was matching there. So if I just change this one to star.py, see how many other py script I have. This regular expression that I'm using here is asterisk, means match anything with dot extension of py. So it found it, but then -i and this, it will show you that it is there up to 7 of them, right? So if I just say, do a -i count, you will see that there are 5 lines that are matching there. And then if I just say, okay, so grep -i, and then look for something like just run cmd. run CMD is two of them, so it should match only two of them, .1, .2. Now, if I just say run CMD followed by a regular expression, 0 through 9, and then it's going to give me the number 1. If I just say the string 1, it will also do that one. As long as I make it unique, it will search that one. So now if I just say run command star, it will just not match anything because the grep minus I run itself is not going to understand that asterisk in there because I have to do a regular expression kind of syntax. So, and this syntax versus the grep command syntax is different. Now, if that is by itself means a star. I don't have to put an asterisk after that one because anything with that one, if I just take this one, anything with R, it's going to do it. If I just take one character, it's going to show anything that has the R character there. So in regard to like R.py, I have to be specific. So I could do that, or I could say R and then put a dot there and then pi here. That would also do it because I'm skipping the /i with regular expression. So grep command, that's supported. That's why it stands for global regular expression, right? So now if I just do the same command here, let's say this, and it shows me one line, but I want to do either that or I could do something, either this, okay, this would match up the same thing, but then I'm going to have another one. I'm going to say env.py. So this one is not going to understand this syntax because this syntax is I'm using a grep command. So in order to do this one, I'm going to do a egrep, which stands for enhanced version of grep. And then right here, what I need to do is have my parameters in a way that I'm going to find out that would work. So I could say r.py or env.py, either one of them, env.py. Okay, so let me, oh, sorry. This one and this one, that's the problem. So this is how you do it. I mistype it. When you do a or, you're saying within one string, either r.py or env.py. So if I want to correct my previous one here, I just close this one and then this one, and I could just still get the output. Now, the regular expression with enhanced version, you could say, I'm also interested in my cmd.py. So I'm going to do that, do my, even if I just do cmd, it's going to match that one. I don't have to put the .py extension. And then if I just say search for something with root, root is already there. And then here I could do another grep command, say -i root, and only pick up the one line. So you could do one argument. By doing piping, you're doing the standard input of this one, the standard output of this argument become the standard input of the second command. And then the standard output of the second command become the standard input of the third command. So the third command, it grips out or with a certain regular expression matching that. I could have just done in one command if I was interested only on the root partition to do this, right? So if I just do that one, everything that was with root, I could just search for it. Now, if I just say, okay, do that one, but now show awk, and then do a print $9. So just the name of the file. And then at this time, I want to manipulate that file. So inside that file, my command.cg.python, I could do a while read here, while read var, and then say do, and then I say echo working on $var and then we say grep minus I. So I'm going to look for the word Python, okay, on each of the file, that one, and then see if Python is used there, and then say done. So this one basically listed, say working on chapter 2, and first line has it. And then the next one working on a command, and then first line has it. How do I know first line? Because I memorized it, but I could do grep minus I with C for count, for N for line number, and you will see that the first line number has that on each one of those ones. So with the grep, awk, set, all of those ones, you have features that you could use the operating system and basically do a lot of regular expression to match it. And then sometimes, what is the neat thing about those ones? So if I just want to change this one, rather than saying this, and then I say, look for another thing called CGI, or just see how many import I used for each one of them. I could do that one and get the import there. Or I say, show me each of the script with line numbers. So say cat minus n, and then the file name, it will just display each one of them. As you can see, if you go on the top, it says working on this one, then it will display the first one, like chapter 2.py, it displays it, and then chapter 2. So regular expression is very good in terms of automation, in terms of picking up information. The script itself, as you can see, it does certain things for you to just do, and then you change the methods or apply it differently for different purpose. Do you have any question? Okay, so let me move on with the module here. We talked about this page basically because I went through the environment variables. Okay, so let me show you on the Unix, for example, this os.environment.items. And also I'm going to show you the CGI method. So if I clear my screen here and I say which Python, then you could see Python -v. It tells me Python -v, it shows 2.714. So what I want to do is change that script vi env.py, and I'm going to put, instead of this, I'm going to say user ben env and then Python 3. So this is how that script is going to execute. So now I have grep minus I Python env.py. You can see on line number 1, now I have this, which means I can do env Python 3, and it will just drop me to Python 3.7. Okay, but if I just do env Python, it's going to drop me to 7.14. So my code needs to run for Python 2.4 for that one, but in general, I want to use Python 3. So like chapter 2.cgi, I want to just do the same thing, user ben env. I already did that one. So that one is already set to go. And then we were using each of these ones. So if I just say env.cgi, because this is, I'm sorry, env.py, because this is a Python script, right away it says, what do you mean line 10? You're using that statement with print. I do not understand the missing parentheses because I use version 3. So version 2, the print statement was okay with without the left parentheses, right parentheses. Version 3 up is all require the parentheses around it. So env.cg.py, now I have to correct that one. So what I do on the VI, I search. In order to search, what you do, escape and then a slash automatically will do this one. Let me just get back here. I'm going to do quit. So here's vi env.py. It opens it up. I'm pressing escape inside vi, and then I put slash so I could search for something. And then in this case, I'm searching for print statement. So right here, print statement needs a code around this and then around this. And sometimes even with this, I could do it for all of them in one shot, but I'm going to show you the lines that are not already within code. I only fixed those ones. So this is already there, this is already there, this already there, already there, and everything is good now. So now if I run the same code that right here it says in v.py, that was failing, now it works. You can see the output is coming. So if I go back to the browser here and go to this one and say env.py, and there, just run it, it just executes it. So now you test it with the first line of the code, having that line. Let's just see if we could do another grep here. I could say, no, actually, this I'm not allowing it to run commands here. So if you do something like cmd is equal grep minus I python env.py, this will be on your query string as the parameter passed, but your commands are not going to be executed because I'm doing some work there that to prevent malicious code. And the reason we are doing that one is that we could do with CGI skip and other ones to just prevent it. And then later on, I will just do the pattern matching with regular expression, saying if the user wants to add a semicolon at the end of the query or some greater sign or some other piping symbols or certain commands that you want to just force it, like rm is not allowed, you could check for those existence of those ones in the key pair value. And if they are there, you just disallow it and say, you're not allowed to do this. Python, so that this one, Python 3, if I go here, and then let me exit out of this and clear my screen. So I'm going to go here, Python 3, and here if I just say import OS, and then dir of OS, you saw that how many methods are there. In this case, os.system, you could put in a command, say cat, let's say minus n, and then say, what is the command name that you want, env.py. If we are allowed to run that command, it will just display here on your screen. And if you just say, okay, that is good, and now just clear my screen, clear screen, and then just go back here and then say head -1 env.py. Show me the first line if I just have the right Python interpreter version. You could just look at your code while you're inside the Python. If you just say, show me a line, let's say cat -n env.py, and then you want to see the first 10 lines, head -10. Then you could just see that. If you want to see the tail of that first, the last line, you could just do that one. If you want to do certain one of them, you could do that grep with the -a uppercase and the size of it. So I could do, sorry, grep -a, meaning after the match. So show me 5 lines after the match of, let's say, if it is matching certain things. In this case, let's say print grep -I print A5. Um, okay, so let me just check something here because the parameter that I'm passing is A for after, but I forgot to see which one is put here first. So let me exit out of this and see if I could do man grep. So for manual pages grep, and you could see if you're doing the grep with -n for a number. In this case, I'm doing -a. B for before and A for after, and C for before and after. But whether you put that string, I think that one is what egrep. And then fgrep, I didn't mention it, that fgrep for stand for fixed string. So you could do the fixed string as well. And let me just do this. So clear screen, minus I print, print, and then yeah. So that it does work actually. Can't open. So this one is not understanding this one, but I think it is has to be egrep, egrep, and then minus A5. Let me see this one. So right here, my Linux clone, I could just start this one, and then I have written a script on it, and parameter that I'm passing in minus, I think it is for egrep, and then either it requires a dash or not dash, but A for after, and uppercase B is for before, and C for anywhere before and after. Let's see if it does. And then you could do the grep command with uppercase E to work like a egrep. This is still running. Show me. It is going to display its own. So let's say I could open it up there and then show it you there, or you could just come in here and say google.com, and then say egrep -A. And the before and after. So this is what I'm looking for here, -A1 for after, and then the string. So the grep command, it does require the A, but I was just putting this one after the string, that was the problem. And I could have tested it rather than open up these other ones. So the way it works is required before. So right here, all it is this one. Even though I have a dash here, I could do this one and just say grep minus A5 line, and then minus I, the string that I'm searching for. And then A5 was not finding it. So grep minus uppercase E mean show that one, but it is not looking at it. Oh, this one is actually, this is the issue. This is a when Linux uses a different Perl versus Solaris. So if I go to my Linux machine, that's what the problem is. So if I go /-lw mywebuniversity.com and then say the Perl interpreter, the way it uses the regular expression on Linux is different than Solaris. So this syntax, it works with Linux. So what I do here, if I just say cat -n etc host, you can see etc host, the local host is on the first line. So if I say grep egrep, in this case egrep minus A, and show me first 3 lines, let's say, first 3 lines after and the word -i, and then the string is local host in this case, inside the file etc host, it will just display it. But that syntax is only working on Linux. This is some sort of compatibility issue with Perl regular expression. On Linux, it is working. On Mac, you have to install a different Perl version in order to work on Solaris. You have to do the same thing that you do on Mac, because Solaris and Linux or BSD version of a Berkeley software distribution version of Unix. And Linux is GNU version, and then that one is more compatible with this kind of syntax. You can see, like, for example, if you're looking for 3 characters before that one, it will show you. And if you want to say, show me more than 3 of them, 5 of them, you will see that. If you say, show me before the local host. So this is before localhost, there's nothing, right? So it just shows you the line that is matching there. But if I'm looking for something like all, in this case, because all is there on the last lines, all nodes, and then I say before 5 lines before that one, then it says etc host, it will find those ones. All is found, and then 5 lines before that one is shown. If I do for loopback, for example, loopback back, and then it shows that before, but there's not 5 lines there. So even though I'm saying 5 lines, there's only 3 lines before and the loopback listed on the etc host file. In this case, what I could do is, instead of doing before, I could say, show me, let's say, before and after. C3 is showing you before and after. So this is the file. I'm seeing 3 lines before and 3 lines after. This is the 3 lines that are matching. In this case, the 3rd line is the loopback, and then after that one is 3 lines. So the -C option is there too. So this is also regular expression syntax, but depending on the OS, different. One of them works differently. On Windows, you don't have a grep command, but you have a find command. You have other PowerShell commands to do, whereas, and so on. Whereas actually, and the class that you want to do to pick up certain information from it. But that's Windows related commands. And the documentation is there for it. And so if you're looking for the whereas command or kind of find command or something, just go to that documentation that I have on this site, mywebuniversity.com. Let me just go our Unix and then man pages right here. This one, so let's say on PowerShell, you're interested to find out certain command, then like where is, Control F, type in where is, it is not showing there, and then the get method or something. A lot of the clause that the get dash process, for example, they may just have the where clause in it. So you just have to read it and then see, oh, the where clauses that where certain thing is matching on the get method. So you could do get dash process and where some condition, like here, see, get process where object is also you could do an alias for where. And this is the full word that you do, or get process is the process, or PS, the alias for it. You have some of them there. So it says where object is working set is greater than 200,000 something. So you could just do that one. And then all of those ones, you have those kind of different formatting. But it is all documentation is always useful. You could learn from it a lot. It's 8:40. Let me see what we have covered on the module here. And I will go on the top and show you some of this. Some of this is good to cover here. Okay. Okay, Python. I'm gonna exit out of my web university. I didn't have to, but I am exiting out because I wanna use one OS and compare it. So Python 3, and then it's import OS, and we did the dir of OS. We see all these methods. Some of the OS method, like you could do, is make directories and this. For example, let's say I say os.system, and then I say run the pwd command to show me what the environment I have. And while I'm doing this one, I could do something different. I could say do ls minus l env.py, show me the env.py, or say grep and grep minus I everywhere that has the print statement. So the print statement is displayed there. And then I want to say, show me everywhere that I'm using the environ there. You can see the syntax that I was giving you. We could say, okay, os.environ. So environ here, let's do the type os.environ to see what is the that actually top os.environ. I wrote it wrong. Okay, so now it says it's a class os.environ, but os.environ.items is a method, right? And so it says collection ABC item view, and then I'm going to look at that class. That is the actual item is a method. So now if I say print os.environ.items, if I just want to print them, I could see that all the environment variables are there. Let me clear my screen. os.system. I want to resize this window a little bit because it is clear command, not CLS. So I'm going to make the property of this display bigger, and instead of 12, I'm going to make it 20 and okay it. And at the same time, I'm going to make this screen a lot smaller on one way. Okay, so this is what I want. At this time, I say os.system, and then I say, rather than os.system, I'm going to run this command, say, show me the printout of all the environment variables. So you can see that items, it has a list of environment variables. The home, for example, is the key. The value is export home w.free, right? So if I just want to do this one and then just say, do show me the home there, print it, and then it's not going to give me that there, but let's see if I could get it like this. It's not going to show it either. So what I could do is to get that key pair values, is there an environment called os.environ I could get it within a for loop for sure. But before I do that one, I want to show you the environment, and there. So one of the method was keys. The other one is, I'm sorry, one of them was items. We want to use the keys this time. And then there's get that I could say get dot. So I could do this one dot get, and then say the home directory is that. If I just print out my home list of the directory, like if I have the thing says path, I know that there's an environment variable called path, I can get the path. And if I just do the other list here to say whether my environment variables, I could get the list of them. So if I just I'm interested on the get of my, let's say my SSH connection, you could see that the IP address will be listed there. And then you could do on the clients and other ones. So what if I just want to do this rather than get individual ones? What if I just want to say, get me the keys? It will give you all the keys for each one of them. And then if you say get the values, like a dictionary, you will see that the values there. And then dot items, since it has that items keep here, I could say here, and instead of doing that, I could say for key and value, and for key per n os.value, and then I'm going to put a for statement here, say print key comma value, and then on the HTML page, I actually parse it the way I wanted to do it. So inside here, you could put all kind of HTML code, which I have done it here. You can see, you can print like H5 tag to just display it on certain type of headers, header 1 through 6. Header 1 is the biggest, and header 5 or header 6 is the smallest. You could put it, or you could put with the font color, like here, you could see the font color HTML, and then size +1. I'm just doing like a kind of like a little bit bigger than the regular font. You could do a bold face /B and a tag or something that if you want to do it. But a lot of those things you want to do it on the main CS3. So like right here, I'm including the CS3. As soon as I say H1, then I could move my CS3 to have a centralized and then certain color and certain things. I could do that too on the page. Let's go back here. Here, this one, we did OS. Now with OS, you could get a lot of the information just for dir of os.en environment, right? So you could see that a lot of these items that are there. The pop, if you want to pop something out of it, get to get that items, and then values and update some values, put env and put env is like env, and set env, put env is similar to get and put that you do on the command lines. There on the, depending on the shell that you're using different syntax. Set env and export, and then those commands are basically depending on your shell. So if I just say here os.system, and then I say let's say and get env password wtree, you can see that it's not allowing me to run certain command. But let's see if I could do a grep -i wtree on the etc password file. And you can see my default shell is user bin bash. So I could do that one, or I could do a ps command, ps for process, and I see that one. So if I do a echo $, on inside Python, I could say echo $, this will just print the process ID of 7778, which is my default shell. In this case, I went to the PS it shows my PS command output. But if I want to see my main process, that is outside of this interpreter. But because I'm already using OS command, and then inside the Python, it says, oh, you're running the command here. If I do this one again, it's going to give me a different process ID, is because of that process ID keep changing. You can see that. But the main one with the bash, I could say ps minus ef grep minus I bash. I could get that bash process ID, and that's a process ID number second. Or if I'm interested on this one, I could do, say, head minus 2. So it gets those two, and then tail minus 1. And then now I have this 1. Then do another awk in it, awk, and then print a $sign 2. So that would give me the process ID of my bash there, but somehow it did not understand. Let me see, tail minus an awk. So invalid syntax, it says that you're using this. So what is happening here? It says that I'm using single quote in both places. I need to double quote outside of it. That way it knows my command is and that. Because here, this single quote already closed this single quote, as you know, from print statement and everything. So Python is consistent, even if you're using it within this module, that it says, okay, you started with double quote here, close the double quote, and then this one requires a single quote around it. That's fine syntax, and it will give you the output that you're looking for. So for the OS module, if I do a dir of OS, there's a lot of file things here. Like, for example, say os.path. It shows me the path of my Python executables. OS. Let's say name to give me the POSIX or NT version of it, what I'm looking for. So I could say, let's see if I say dir of os.stat, does it have a method? Yes. Stat also has that one. So if I say stat on the file called env.py to get the statistics on that one, and I want to do a print on it. So I have to close that one, and you can see this one. Let me do os.system clear screen. So this one, if you just do something like this, it just says, okay, env.py has this modification information. And that information, I could also get it from this command by saying stat minus L env.py. If a stat is not provided on this machine on the Solaris site, it will be a problem. So what I could do is here, I say, okay, that is fine. Let me just see, and that I have to install stat in order to get it. And the reason is this, is that I could go back here on this this screen here and open up another shell and just resize this one and to also make it smaller. So this command did not work, because if I say which stat here, the stat is there, user ben stat, and then etc host, and that is giving me the information. So why didn't not give me that parameter? Because it did not understand the -l command. So -l is not listing there. And then in this case, I wanted to do stat on that file, env. You can see that the file is statistic is there. And then the same thing with the OS module, I could do this kind of thing, OS env, and you get it. But notice the output of this one is similar to this one. This one is giving you a cleaner output. And then here, you're getting this output in that format. So if I just send this one to a kind of a x is equal that, and then say type of x, you can see that is os.stat.result. So this is not like a list or something that I could just print it and saying that to send it this. It's a statistic result of the OS, which is coming in this format. So each one of these fields is a key pair value only if I just store it in that way that I can say the device is there, the stat of inode number, the number of links that are there, the modification, access, this is the size of the file, the group ID, this is the user ID, the access time, the modification time, and then the change time. All of that information is there, and then here is a little bit more readable than cryptic kind of abbreviation for a developer. So you could get this kind of information from this. If I just say os.system and then I say pwd. So now if I say ls minus l, so let's say I'm going to say ls minus l new dir. Do I have a file directory? No such file. How I do that? When I could do a command here, make dir, and then now it says permission denied, because the way I logged on to this machine, I don't have that permission unless I just do it at a different level. Why does it say permission denied? Is because if I go here and say pwd, what directory, I'm on a CGI bin. And this directory, if I do ls minus ld, because of the outside, I don't want to leave it open, and CGI bin is protected by root. So other people could not make directory or things except the root, the owner. But /temp is open. So if I look at /temp here, I could do that one /temp. I'm sorry, not the dot dot. So this one is /temp. I could say, go ahead, make dir. Make dir /temp is temporary for a file system for everybody. So I say create a new dir. Now it just says 0 means successful. If I just do ls minus ld again here, you see that it created. Now if I just say go ahead rm it, rm dir, it just removed it and now it's no longer there. And then what if I just, instead of the system, I could say make dir and then use the Python os.makedir things. It says here, it says /temp/new dir. That would be the same equivalent rather than using that. So now I do the ls minus l command is there. And then if I just look at the make dir, for example, I could do rm dir is the same thing. And now it's no longer there. You can see. So for dir OS itself, you can see that there's a lot of commands that are available, a lot of functions that are available. os.sys for system related things is like do a type os.sys. This is telling you it's a module sys, and if you just do just help out and self, this is extensive information about the sys modules. So you could do also, like for example, import sys is similar. So sys dot executable, like for example, if you want to see what is the Python version, you could say version info, or version information, or version itself. It will tell you those information. Dir of sys, it tells you a lot of the function in the other one. The standard input, the standard output, versions, sys dot, let's say path, to see the path of your CGI script and Python script and everything else. All of that one is there. Let's do the dir of os.sys to see what are the difference. And same functionality that are there is available here. So, and then if I just do import, let's say sub process. Sub process is similar to OS, but it's a little bit more neat in terms of this. So sub process is a module, and there of sub process, you can see it has a lot of functionality. And then on the old days with version 2.4, it had certain call and other ones. Now this run sub process is available. And then you can see sub process.os is there too. So if I say import a sub process as SB sub SB for sub process, I should have done SB, doesn't matter. So dir of SB in this case is telling me that, and then dir of SB.os is giving me all the commands that I could have done with OS. And then, for example, subprocess.sb.run, and then I could type in the commands that I want to do. It will just do the same thing. So uname -a, and you could see that subprocess, certain programs requires certain arguments. In this case, the system, I have to do like comma, and then since I'm using it not like a subprocess, basically when you do this one, it has to be a list. So I have to do uname here, and then minus a comma, and then -a as another one, and then close it. This would be a command that would just do that. As you can see, uname -a, because of that, it allows it to run it. So if I just say cat, and then -n, and then now I have to have another list here, say the file name env.py, that will just run that one. And the file while the string is there, yeah, and then I just missed a single quote here, and that would display it there. So each of these processes that modules that are available, it gives you certain functionality. Clear command. I'm gonna do import CGI. So CGI, what is CGI? Common Gateway Interface. There of CGI, you can see there are some methods that are available. One of the methods that we may be discussing next week is URL lib. URL lib is also used for kind of like URL interpretation of just going through HTTP protocol and connecting to URL, which is google.com or amazon.com or nasa.gov, whatever the website that you're connecting to, you can do that one. And then there's request method also that is available with request modules. We will discuss some of those ones next week, socket programming and everything. But CGI, Common Gateway Interface, as you can see, the CGI has this storage field. There's something here that is called storage field. Let me see, a string. Yeah, field storage right here. Field storage, so each thing that is coming from the form, when you're inside the CGI script, it will be stored in the field storage class. So, and this is a class. So if I say type CGI.field storage, you can see it's a type of a class, right? So if I just say print it, it is not having anything yet, but when we actually connect to the methods that are there for the forms inside there, all of these fields are going to be applicable. Like get the value, for a key, you could get the value of it. You could list the keys and then do this one. Since I'm not pointing to anything, if I say get keys, I may not have anything to just look for, right? So this is the options that are available for it, but inside my CGI script, I could say, oh, now I connected to this URL, and then that's get method is called, the get method passed on to that one, then I can just pick up certain information. Any question? Okay, it's 9 o'clock. I haven't taken a break, and you guys haven't taken a break. Let's take a 10-minute break, and then when we come back, we're going to discuss this assignment that we have. Let me see what is next after this one. Yeah, these information we already covered for regular expressions that you could read a lot of the materials with the textbook. So it's already posted on the previous chapter as well as here. So you can go through all the examples here. But I'm doing a regular expression substitute command or method that you could practice with it at the lab time. Today I'm going to give you some lab time also to practice some of the example from last week and work on Unix if you have a Unix environment, or just go on this page and see some of the things yourself. Obviously, some of these ones are just for my local stuff. I'm not at this time 100% on it. So some of the CGI scripts and other things are not producing the man pages that I want, but the man pages that are on the website here that we looked at, and they are available on this kind of a man page everywhere here is already available. So you can go and read it for depending on which OS you want or what command you want. So for each one of them, you get a big list, and then you can practice with it. Coming back to this one, so for today's topic under the module, I tell you what we're going to cover after the break, and then I'll stop recording after this, and then I'll explain the assignment. Then we take a break, and after the break, you come back, you're going to work on the lab activities of your own. And then I'll be available at any time till the office hours, so you can ask me. And then with office hours, I'll be available after 11. And so actually after 10:10, which the class ends, till 11 or 11:40, whatever time you need, I'll be available. So please ask me a question if you have any question. Let me go back to the module for today. And right here, as you can see, for week 11, we have chapter 11, assignment 1. You open this one, basically, my expectation for you to do is to just have a small N file. This N file.txt, you just cut and paste this one, save it as file name called nfile.txt. Then you write a program in Python, and you name your program assignment chapter 1101, your last name.py. Once you save it with this name, inside your code, depending on what shell you use, what operating system you use, whether Windows or Unix or Mac or Linux, in either case, Mac is basically a Unix. It's based on BSD. It's not, Mac is not Linux. Some people, they say Mac, Linux operating system. That's not true. Mac is based on BSD. Darwin version that is running is based on Berkeley software distribution, and that is a Unix operating system. Linux and Ubuntu and Caldera, Red Hat, CentOS, all of those ones are Linux. Solar is another BSD version of Unix. FreeBSD is also a Unix. SunOS 1 is DEC OSF 1, they call it, or HPUX. They're all Unix. There's a lot of other ones that I used, a Clipper version of Intergraph called Clex, that's also Unix. and then there's a Xenix of Microsoft version for Linux, that's Xenix basically is called. And then there's other micro version of Linux also that is available for the virtual boxes that you do mostly are Linux based, but the one that I'm using is my Mac, not my Mac, my Solaris. That one is SunOS Solaris operating system. Solaris as a Unix operating system. So in this case, when you do this name, let's say you did it on Windows, make sure your header information has the first line with shebang Python. And then if you're doing it on Mac or Unix or Linux or any other version of Unix, Linux, make sure you have the right header information. On the second line of the header information, make sure you put your last name, first name, and you know this is assignment, what did this script does, that kind of information. Maybe 3 or 4 lines is sufficient enough to just be descriptive. And then if you put a comment section for the documentation with 3 string, that will be useful if somebody wants to read while they're inside your Python script, they could get the document magic method of it to see what you're using here. So in the example of infile.txt, I'm expecting you to write a Python module or Python script with this name to search for a string like this. Whenever it finds out duplicate characters that are not making sense, duplicate characters that are not English words, like C is an English word. Let's say good is an English word. It has the food is an English word, right? It has 2 consecutive O here and 2 consecutive O here, and then here 2 consecutive E. I don't want you to modify that one. But if a string is like this, every character is duplicated and it does not make sense, then you need to convert that one to C also. So this C also, you can see this is 4 of them. It should be only 2 E, but this one is 2 S. It should be only 1 S. So there's a trick that you have to look at the next element in the string and then see how you could parse it with your patterns, how you do the pattern matching with those ones. I want you to be thinking a little bit outside of the box of what we have covered there, and then what you could come up with a method of pattern matching to do a re.compile and then put your pattern matching and then just run it there. You don't have to do the re.compile as the pattern. You could say pattern is equal and then put the pattern and then just look for that pattern. And if that pattern is in this strings, make sure that your output is going to show like this. You see the C also, it is correct, even though it has here more than just 2 E's. And then here, this string with food and health and the word food and good is appropriate English. So you don't want to just reduce 2 O's that are lowercase here that are making sense. But here, this one, 2 O's that are uppercase, you don't look for the word uppercase to say if it's uppercase, I'm going to convert it. But what if I just type in on this string here the word food twice good? So in order to actually make sure that if your code is only looking for double code somewhere, I'm going to add one more string here and all in uppercase with those words. But this script should not fail if I have that information. Let's say I'm going to just put here food and good. So this should be produced back to itself. The other one, if you're looking for uppercase O, your code will break here. So please make sure that you don't check for by forcing for certain words. You have to do it programmatically. So let me see, I love, before I love, I'm going to put that one. So the output should, for those two, should be back to this. Okay. I'm going to save it. And this is due next Thursday at midnight, so you have a week to do it. Please try to work on it by yourself. And if you use internet or Google or search or talk with a friend, it's okay. That's what you normally should do. But make sure that your code is not exactly like your friends or someone from the internet. That would not be a good idea. This is basically the information that should be outputted. So you can use the with statement with open to do context manager, or you don't use the with the context manager, but if you don't, make sure the file handle that you open, you close it yourself. But the method that you're using is all your choice. What regular expression pattern you use, you have to use the regular expression modules, and you have to use to read the file as input. Then whether you want to write it on the screen to display this output, or you want to write it to another file, and then that file, if you choose to write it to a file, you could say whatever outfile.txt, or you say outfile underscore your last name.txt. So when I run it, it does not overwrite the previous person. But even if it does write it to the previous student, I could just run the other program again and look at the code and save it different. That's not an issue. What I'm trying to make sure that you can read a file, you do regular expression pattern matching on it, manipulate it, and then parse it. And then once you're doing it, tokenize it and produce the output, either produce that output to a screen or send it to another file. If you can produce it at a screen, like you read the other files, you can write to the file as well. So that's not a problem. Do you have any question on this? I hope everybody is clear on it. So it is due next week on November 12 at 12 a.m., which is midnight, 11:59. And at this time, I'm going to stop sharing. And if you have questions, please ask me. I'm available until everyone is available. And if you're not available after 11:40, I will be signing off. But I'm available again for the lab activity. Let's take a 10-minute break, and when you come back from the break, you can use a Python interpreter the way we want. You can practice on this chapter or the previous chapter with regular expression. Okay, thank you so much. And if you don't have any question, you drop off after 10, which I am expecting everyone that are here to participate on the labs and ask me question. If you drop after 10, that's also okay. And then you can just send me emails when you have question. Have a nice one.